Alrighty, let's see what we got. I did actually spend a little more time on yesterday's hard problem that broke my streak, but I didn't get anything. Got a little closer, like I think I got to 10 test cases that were wrong, but unfortunately I put it on the back burner by now. Alright, let's see what we got here. Maximum number of distinct elements after operations. You're given integer nums, integer array nums and integer k. You're allowed to perform the following operations on each element of the array at most once. Add an integer in the range of negative k to positive k to the element inclusive. Return the maximum possible number of distinct elements in nums after performing the operations. Okay. So 1, 2, 2, 3, 3, 4. Maximum number of distinct elements. So you can subtract 2 from here and get 0. You keep the 1, you keep the 2, keep the 3, keep the 4, make this other 3 into a 5 by adding 2 to it. So 0 through 5. Okay, or you can make the 1 into a negative 1 and the 5 into just a 3. So yeah, so 0 through 5 or negative 1 through 4, it's going to be 6 elements. Here you can make a 4 into a 3, make a 4 into a 5, and you have 3, 4, 5. Okay, I can understand it. It's reasonable enough. I almost certainly want to sort this if it's not already pre-sorted. So question is, I think a greedy approach is probably fine here, in the sense that after I sort it, I can make each element into the lowest value that hasn't been already added to the distinct set of nums. And yeah, I make it into the lowest value that it can possibly be, iterating over the sorted elements. And if there is an available slot, then it would fall into that slot. Yeah, I think this is just a greedy approach here. So what, I guess the lowest value minus k is going to be the lowest thing. Okay, so I think it's going to be answer is equal to 0. I think I go current is equal to like negative infinity. And then for every value in nums, current is like the current last distinct element. This is just a dummy element, last distinct element. And I think I can do something like so for every value I find that value minus k. I just find that value minus k. So every value can become value minus k to value plus k. So if my current is like, let's say negative 100, and let's say my value is 20 and k is 5, then this means it can go from 15 to 25. So I'd obviously use 15. I would make the value into 15, and then my current becomes 15. So the value either becomes the minimum, no, the maximum, if the current is less than the maximum, then less than or equal to, I think it has to be less than, then the current equals, I think it's going to be like the minimum of current plus 1 . It's the minimum of current plus 1? The maximum of current plus 1? So the current is a negative 100, so it should be negative 99. I think it should be like whatever is bigger between current plus 1 and val minus k. So if the current's negative 100, then the next available should be negative 99. Or alternatively, it could be 15. And I should use 15, because that's the only thing that's actually in range of the value. But let's say the current is something within this range. Let's say the current's 17. So the maximum between 18 and 15, so that'd be 18. Yeah, I think that's right. I think answer needs to increase at this point. And then what happens if the current is greater than or equal to the value plus k? If the current is greater than or equal to value plus k, then I ignore this value. I think I just skip it, because I guess it'd be like a current is 1,000 and the current value is 20. There's just no way that that value can create a new distinct element. I think that's it. All right. I guess I could possibly create an and here. And current let's see. Current equals the bigger of the two. I guess can't do an and right there. I'm surprised this is so slow compared to the other solutions. This just seems pretty short. negative infinity, sort, answer equals 0. I think maybe, wonder if I can skip elements somehow. Current is less than value plus k. Current equals maximum of value minus k and current plus 1. I guess I could do something where, can I always increment current somehow? Don't think so. Don't think so. I wonder if there's a different logic I can do besides what I'm doing. I don't know. I guess trying to optimize this is kind of stupid. Whatever value in nums, if the current is less than or equal to k. Current equals negative infinity. If I look at this, is there some way for me to automatically figure out? I mean, this is not pre-sorted, right? Doesn't seem to be pre-sorted. I mean, I guess maybe sorting is the slowing function. I wonder if I can do a linear approach without sorting. Could I do a linear approach without sorting? It might take more memory, I guess. So I could do like a hash. If I did a hash, no, that's just so bad. Hash is just going to be maybe better if there's a lot of duplicates, maybe. Could find the minimum and the maximum in constant time. And then if I find the minimum maximum, what does that even do? All comes down to sorting. Does it? I think it does. If I imagine each number as an actual range, so this is -1 to 3, 0 to 4, 0 to 4, 1 to 5, 1 to 5, 2 to 6. 1, 2, or 3 to 5, 3 to 5, 3 to 5, 3 to 5. I think about the actual ranges. Somewhat tempted to peek into what these guys actually did to make it faster. Because I can't really see it. Alright, whatever. Summary. This is kind of a greedy approach. For each, okay, track the last, sort the array, track the last distinct value that is added, dummy start value is negative infinity. For each element in sorted array, find the lowest unused element value that could be. So look at the example above. So if the current is negative 100, the value is 20, k is 5, the value can become a range of 15 to 25. So value should be set to 15, obviously, right? And then the logic there would be if the current is at all less than what the top end of the range of things are for this value, then there should be some possible distinct value that you can change this to. And that distinct value, if you want the lowest possible, then it'd be current plus 1 or value minus k, with the max between those two. And then set the last distinct to what the current is changed, what value is changed to, and increment answer. If not possible, then go to next value. That occurs if, like, you see a bunch of 4s, the current becomes like 10 or something, and 4 plus 1 is not going to be anywhere near 10, so you skip all the 4s, like in example 3. Alright, time complexity is going to be O of n log n to sort the array. The actual for loop to find answer based on sorted array is O of n. I'm unsure if there is a way to solve without sorting. If there is, then it might be faster than O of n log n. If this was a more limited set of values, not like infinity to infinity in terms of the numbers here, like you could actually make a fixed sized array that could iterate over those things. But it's kind of big. And I'm unsure if there's a hash way of doing, like doing a hash table Unsure being I don't know. Space complexity, this is just going to be of 1 since no extra space is needed.